Join me on this episode to learn how to build and operate the STMicroelectronics Robot Evaluation Kit. The kit features a camera module, sensors, wireless connectivity, motors, and a powerful microcontroller. It's a great way to explore embedded processing, motion control, and even vision-based applications. Hi, welcome back to Tech Ventures. My name is Lazina, and I'm a technical marketing engineer here at Future Electronics. If you're interested in checking out any previous episodes, then please feel free to click the link on the screen or check out the description box below. I'm so excited for today's episode because we're building a robot, and not just any robot. We're using the robot kit from STMicroelectronics. It's a fully functional evaluation kit that consists of motors, wheels, of course, a camera module, and a powerful main processor board that leaves room for future upgrades. So grab your screwdriver and let's get started. Actually, you'll need more than a screwdriver. You'll also need a pair of tweezers and a flat driver. So first up in the box, we have the main board. This is the brain of our robot. It's powered by the STM32H7 microcontroller, and it handles coordination between all the different components. So it connects to the motion sensors on board, like the IMU, which gives us data on acceleration and angular velocity. This is critical for navigation and stability. It also connects to the magnetometer, which reads the magnetic field around the robot for directional awareness. And we also have a MEMS microphone on board to capture audio, making the robot a bit more interactive. And for wireless communication, there's a Bluetooth Low Energy module which connects to a mobile app. Next up, we have the motor board. This board handles all the things to do with movement. So it's powered by an STM32G07 microcontroller and uses motor drivers to control the speed and direction of the robot. Just like the main board, it also includes an IMU sensor, which continuously sends motion data to help with real-time motor control adjustments and overall stability. Next in the box, we have an imaging board. This lets the robot see and respond to its surroundings. It includes a camera module and a time-of-flight sensor. Now for the rest of the box, we have a battery pack. You'll need 4 AA batteries, not included, 2 DC motors, spacers and screws, a bunch of cables. So there's a motor cable with ferrite cores, a flat ribbon cable for the debugger and board-to-board connections, mounting hardware for the camera, and of course, the top and bottom chassis, plus 2 wheels to bring our robot to life. All right, let's get building. So first off, we want to start by attaching the metal brace to the blue motor driver board using the long screw and nut. Then we'll screw the motors onto the bottom chassis. Don't forget to remove the stickers first. So orientation matters. The metal shafts should face outwards. This is where the wheels will attach later. So insert the screws from underneath the board to secure it. Next, we need to attach the freewheel to the bottom chassis. So we need to unscrew the screws on the wheel and then screw them back on to attach them to the bottom of the chassis. Next, grab the top chassis and screw in the larger acrylic support bracket. Insert the screws from the bottom and fasten them with the nuts on top. Mount the smaller acrylic bracket on top of that. There's a recessed area for the nut. Drop it in. It helps if you're holding the nut with the tweezers, and then secure the bracket with a screw from above. Now add these plastic screws near the bracket for the camera. Carefully place the motor control board onto those 4 plastic screws we just installed. Now screw in the 20mm spacers on top of the motor control board. This will be used to support the MCU board in a few steps. Now let's mount the battery holder and fuse support, so you can use the double-sided tape to hold them in place. Let's turn our attention back to the bottom chassis with the motor drivers, which we have prepared earlier in step 2. This will be the bottom layer. Secure the 25mm spacers using the nylon screws. Now we'll need to attach the ferrite cores to the motor cables and attach the cable between the motor and the motor control board. And now we can assemble both chassis together, secure it with a screw. Connect the flat ribbon cable from the MCU board to the motor board. Place the MCU board on top of the motor control board. Secure it using the nylon screws. Then connect the motor control board to the MCU using the flat cable. Now, time for the fun part. Attach the wheels onto the motor shafts. And we'll install the fuse and the battery holder. Hook up the power supplies. So the red wire goes on the left and the black wire goes on the right, and secure it in place with the screwdriver. Next, we'll mount the image sensor board onto the MCU board. Make sure the blue side of the MIPI ribbon cable is facing upwards. Secure the board to the bracket with the screws. And now finally, download the Companion mobile app to start interacting with your robot. And that's it, our robot is fully assembled and ready to roll. In part 2, we'll power it up, connect it to the accompanying mobile app, and I'll show you how to control it, how to monitor real-time data, and we'll even go for a little test drive. Thanks for building with me today, and I'll catch you in part 2.